Alright, in this video we will see the chain rule applied to some transcendental functions. So I'll just continue to do some examples, but before I continue, let me just rewrite the chain rule. So if we had y equals f of g of x, that was our function, then dy dx was equal to f prime at g of x times g prime of x. That's basically the chain rule in a nutshell. That's at least what you should remember for the most part. Now, transcendental functions include the 6 trigonometric functions that we love, as well as the exponential function and the natural and logarithmic function. So let me do a couple of examples using sine, cosine. Although we saw a few of them, it's important that we see them in isolation. So let's begin with the following example. Let's find the derivative of the following. Y equals sine of 2x. It is important that you identify quickly what u is. Here, u or g of x is 2x. I'm going to use g of x because I wrote the rule with g and f. But you know, g of x is the same thing as u. It's the inner function. Then f of x is simply sine of x. Okay. So what is the derivative of g? G prime of x. Well, the derivative of 2x, remember there's a 1 up here, is 1 times 2, which is 2. And then 1 minus 1 is 0, so that's just 2. Because x to the 0 is 1. And 2 times 1 is 2. Then f prime of x is equal to, well, the derivative of sine of x is simply cosine of x. Alright, so when we do this composition, when we take the derivative of y, we know that it's going to be f prime evaluated at g of x times g prime of x. So that means that this is going to be equal to f prime, which is cosine, evaluated at g of x, which is 2x, times g prime, which is 2. So that means that y prime is 2 cosine of 2x. So notice that the derivative of y equals sine of 2x is equal to 2 cosine of 2x. So the derivative of sine times the derivative of the inside. So another one. What if you're given now cosine? So if somebody comes up to you and gives you cosine, let's say, of x minus 1, then again, this inner piece is your g of x. And then the outer piece, which is just cosine, is your f of x. So f of x equals cosine of x. Once again, let's take the derivatives. So g prime of x is simply 1, because the derivative of x is 1, the derivative of minus 1 is 0. And now the derivative of f of x, we know that this is negative sine of x. So again, you have to memorize it. The derivative of sine of x. So if you take the derivative with respect to x, it's going to be equal to cosine of x. And if you take the derivative of cosine of x, it's going to be equal to negative sine of x. Okay. So let's move on with this. So y prime of this, the derivative of y equals cosine of x minus 1, is going to be f prime, so minus sine, evaluated at g is equal to x minus 1, times g prime, which is 1. So y prime, the derivative of y, is equal to minus sine x minus 1, because when you multiply by 1, you just get minus sine x minus 1. Alright, let's do a third one. Say you have y equals e to the 3x. Now, before I had told you that the derivative of e to the x was e to the x. So recall, if y equals e to the x, then y prime was equal to e to the x. That's what I had told you before. That's because I didn't give you the full rule. So what happens? here our function g of x is the linear function 3x, and our function f of x is equal to e to the x. What is g prime of x? I mean, what is the derivative of 3x? It's just 3. What is the derivative of e to the x? It's just e to the x, because of this rule. Now when we put it together, when we say, okay, y prime is f prime evaluated at g of x times g prime of x, what do we get? Well, what is f prime? F prime is e to the x. But I'm going to write it in this way so you can see what I mean. So this is e to the g of x, because you're evaluating it at g of x, times g prime of x. Well, what is g of x? It's just 3 to the x. So this is equal to e to the 3 to the x times 3, the derivative of 3 to the x. So that means that y prime is equal to 3e to the 3x. This one is one that you should also practice a lot, because it comes up throughout the whole semester. If somebody comes up to you and gives you, let's say, y equals 2e to the 4x, then you should be able to immediately say, okay, the derivative of this is going to be equal to 8e to the 4x. And the reason for that is because when you take the derivative, if you do it slowly, if you say g to the x is 4x, then g prime of x is 4, and then f of x is simply e to the x. I mean, you could say even 2e to the x, that's completely fine. And f prime of x is just 2e to the x again. Now when you put it together, y prime, you have 2e to the x, but remember, this x here represents that g to the x, so that's 4x, times the derivative, which is 4, and 2 times 4 is 8. So you have 8e to the 4x. So that's what y prime is. I'll do one more problem with e to the x right now, because they're pretty important. This is 5, I think. Oh, not 4. It's example 4. So let's do one more with e. So this is y equals 3e to the 2x cubed. Alright, so what is g of x? Once again, g of x is the top piece, so this is 2x cubed, meaning the exponent. F of x is simply 3e to the x, let's say. G prime of x is going to be the derivative of this. That's just 3 times 2 is 6, and 3 minus 1 is 2, so this is 6x squared. And then f prime of x is simply 3e to the x, because of the constant multiple rule. Now when we put it together, once again, f prime is f prime evaluated at g of x times g prime of x. We now have that y prime is equal to 3e evaluated at g of x, so that's evaluated at 2x cubed, times the derivative of g, which is 6x squared. So what we have now is that y prime is equal to 3 times 6, which is 18, x squared, e to the 2x cubed. So there's now, we have now an x trailing, because it came from the derivative of g. So this is much like this problem here. The only difference is that here we didn't have an x trailing in the problem. Okay, let's talk a little bit about when we have to apply the chain rule more than once. I did an example like this. There was the last example, the second to last example in the first video of this lecture, which was a little bit longer. So let's try another one like that. What if somebody gives you, let's say, f of t equals sine cube 4t? Well, the first thing you should always do is rewrite it so that it looks better. We could rewrite this as simply sine of 4t cubed. And this way you could actually see that we will have a case of the general power rule. When we apply the general power rule to this, when we take the derivative of this, remember you're bringing the 3 to the front, so you're going to have 3 in the front. The inside is going to stay the same, or so you think. So you're going to have the inside, which is sine 4t, right? And we minus 1 from here, squared. But now, because of the chain rule, we have to multiply by the derivative of the inside. But the thing is, the derivative of sine 4 of t is also a chain rule itself, because this is 4t and not just t. And the derivative of sine 4t, let's call this y. The derivative of this is cosine of 4t times the derivative of 4t, which is 4. So that means that y prime is equal to 4 cosine of 4t. So here we actually have to apply the chain rule twice, because when we take the derivative of this, this in itself involves a chain rule. So we have 3 times sine of 4t times the derivative of sine of 4t, which is 4 cosine of 4t. And then when we simplify this a little bit more, we have f prime of t is equal to 3 times 4 is 12. So I'll say 12 cosine of 4t times sine square of 4t. I think this makes it look nicer. Okay, and that's the solution for this problem. So here we have to apply the chain rule more than once. I'll give you one problem as an exercise in case you want to try this before you do the homework. Let's say g of x is equal to cosine of 8x squared, the whole thing cubed. Okay, it shouldn't be too challenging. It follows the same steps. You're gonna do the power rule, bring the 3 to the front, minus 1 of it. You're going to take the derivative of the inside, but that inside is also going to require you to use a chain rule. And that is it for this part of the video.